Hello everyone, so today we are going to be doing a small demonstration of the solubility rules. So what I have here is I have a bunch of solutions like barium nitrate, ammonium hydroxide, calcium chloride, etc. And I have them arranged in a little table, and what I'm going to do is I'm going to take a drop of each and add them together and see what happens. If we combine these two solutions and they form a solution that has no reaction, then we will expect the drop to remain colorless. So you can see these are both colorless liquids, and when they react, you can see there the formation of a precipitate. So what is that precipitate? Is it barium carbonate or is it sodium nitrate? Well, we go to our solubility rules, and we can actually determine that barium nitrate and barium would not be soluble with a carbonate because barium is a row 2 element. So I'm just going to put some drops here. Oh, try not to mess up. If you put them on the X, you can actually see a really nice reaction very clearly. So there's my barium. So now I'm going to use a source of chlorine. I'm going to use, it doesn't really matter, I guess I'll use sodium chloride. I have it anyways. So here's some sodium chloride here. So barium nitrate mixed with sodium chloride. And it looks like no reaction. Okay, so chlorides are soluble with most things, so I'm not too surprised that that's the case. Now I'm going to get my sodium hydroxide. Now hydroxides have a low solubility with many options. So let's see what we get here. Yes, you can see the clouding up there and a little bit of a color change as the sodium hydroxide touches. This is, I've got nitric acid instead of sodium nitrate, so hopefully that'll be okay. Now I shouldn't get any reaction because this is actually making barium nitrate again. So barium nitrate and barium and sodium nitrate should give me the same result. Okay, let's try the phosphate. And we do see some clouding there. So that's barium phosphate and barium phosphate being formed. And now let's see if the sulfate is also insoluble. Yeah, that one's very insoluble. So you can see that distinct reaction forming there. Okay, so maybe let's see if we can save ourselves a little bit of time by putting a drop down the row here. Okay, so there's my sulfates. You know, doing this quickly is probably not actually going to pay off, is it? I'm just doing this on top of a transparency so that if I need to, I can just wipe it up and it won't cause trouble. There's some, if we're being really scientific about this, then we might start to worry about, you know, evaporation could have an impact. This is a particularly concentrated sodium hydroxide here. Okay, so we're almost there. We're going to just put the sodium chloride down. And let's see. It'll be fun to see. There's a couple of these reactions which are actually going to be more interesting. I did have to do a couple of substitutions, so we'll see those. The next one, I believe, is the first substitution I had to make, and that is the substitution of ammonium chloride for ammonium hydroxide, and that's just simply I didn't have any ammonium chloride right now. biggest trick is when you have one of these sheets is not to drop your arm in it. Oops. Oh, that's not good. This stuff is pretty concentrated. Just 1 second. See if I can clean that up. Two more drops here. Of course, no. No. That'll be a mess. Unfortunately, if the paper is not absolutely dry, you can't get the next drop to sit nicely. All right, let's try it one more time. I'm sure this is very thrilling. There we go. Nice drops. Okay. Okay, so let's go on to the next one. The next one is sodium hydroxide. This should be okay as a replacement because none of the other compounds, all the compounds along the top have sodium as the counterion. So I'm really just exploiting the ammonium with the counterion of the compound I'm mixing it. So let's see. And here we go, ammonia, no reaction. Ammonium and chlorine, no reaction. Ammonium and hydroxide, no reaction. Ammonium and nitrate, no reaction. Phosphate, no reaction. And I'll just even drop an extra drop there. And sulfate, no reaction. And we, of course, know from our solubility rules that ammonium is not supposed to have a reaction. All right, so let's go to the next one, which is calcium chloride. I'm just looking around for my calcium chloride here. I just had it. Magnesium, barium, strontium. Okay. Oh, there it is. Okay, so here's my calcium chloride. So now we're mixing calcium with a carbonate. We should probably get a reaction there, but this calcium chloride might be too low concentration. Calcium chloride with chlorine will have no reaction. With a hydroxide, I am seeing a reaction. You might not be able to see it from where you are. But there is a reaction here in the calcium chloride. It's just a little tiny bit cloudy. I'm not sure if I can zoom in there. You can see a little bit of cloudiness, not too much. Okay. It is a swirl though. Nitrate, no reaction. Phosphate, I do get a reaction with the phosphate. And the sulfate, not a clear reaction. So I would say that I'm only getting a reaction here. I'm going to try it. PPT, PPT, now that I'm close enough. And the carbonate, there might be a little bit. I'm going to go with a slight PPT on the carbonate, but not very much. Okay, so that is interesting because I think in our rules, calcium should have formed a reaction with the sodium sulfate. But that sometimes depends on the quality of the solution. So the solution might not be strong enough. Okay, this is copper sulfate. So copper sulfate's blue in color. So let's see what happens here. Oh, you can see a very distinct splotch there. That is the precipitate reaction. If it's blue in color, that's okay. That's just the dissolved copper, but here you can see with the copper hydroxide, you can actually see a powder that is forming. No reaction there. There is a reaction there, and I believe that sulfate should be okay because this is copper sulfate. So when we mix copper and sulfate, we get no reaction. So we could also go in, it might be worth writing PPT. Oh, just got on my pen. And PPT. Okay. So hopefully that should agree with any expectations we had before we started the experiment. Okay, I've got some sodium chloride here. I'm going to put that across. I'm expecting almost no reaction because, in fact, I expect absolutely no reaction because sodium is soluble with essentially everything. And so there's the case. There's no reaction. Very unexciting. This is the iron chloride. It's yellow in color, and that's because of the interaction between the iron and the waters. So there is a nice distinct solid forming. That one is no reaction. That one is some reaction. No reaction. Oops, that's just an air bubble. Let's try that one more time. That one's hard to say, and let's try the sulfate. Sulfate looks like no reaction to me. So it looks like only the phosphate had a slight reaction, but really the strongest reaction was definitely that carbonate. So iron carbonate, definitely a precipitate here. And I also see a precipitate in the hydroxide. Looks like I can see it here. When I get really close to it, I can see a little bit of cloudiness. Sometimes you can take a little toothpick and you can stir them around, see if there's any extra reaction there that you can get through a little bit of stimulation. Okay, here's my lead nitrate, so it's a clear compound. Distinct reaction. No reaction. Distinct reaction. No reaction. Very strong reaction. Very strong reaction. So lead in general has some very strong reactions. It's a bit of on the smaller side of the ions. It's also in the of the metals, or especially the weak metals. It's in the main group, so it's below. It's below carbon. It's in the same group as carbon. So that gives it some interesting bonding abilities because of its s and p orbitals. So here we got a strong precipitate. So typically true bonds or ionic bonds with lead are very strong, and so it doesn't actually really have much interest in being dissolved in water. Okay, we're going to take some magnesium now. Where is my magnesium? Oh, magnesium sulfate. And let's see what happens. A little bit of a reaction there. No reaction. Maybe a little bit of a reaction. No reaction, no reaction, no reaction. So the hydroxide does look like a slight reaction. Usually hydroxides are insoluble, and the carbonate is for sure. So if you're a little bit farther into the unit, you'll know that there's what's happening is we are actually getting the formation of some equilibria here. So we aren't necessarily expecting a full reaction from all of these things that are considered insoluble. We are really, oh boy, I've got a container with almost no potassium iodide. Oh, there's another one. Okay. So we are seeing almost no reaction in some of these cases. Here's potassium. Potassium is a first row element again, so we are not expecting strong reactions. First column, I should say. And so potassium has no reactions. And then the last two here, I have silver nitrate. So that's my silver nitrate. It's just a nice clear. It's sometimes a little bit brownish in color. And so there's a very strong reaction with the carbonate. Strong reaction with the chloride. It's the only one that has a strong reaction with the chloride. Strong reaction with the hydroxide. No reaction with nitrate. Strong reaction with the phosphate. And looks like no reaction with sulfate. So this is the silver's reaction. We can even see there's some interesting colors coming. So these different solids, they actually will deflect light in different ways or interact with different photons and they'll become colored crystals. So a lot of different ways that color can come in crystals. That's really beyond the scope of what we need to talk about, but it's usually related to either scattering of the light, or in this case, these are tumbling around in water, so it's probably more that the bonds themselves interact with certain wavelengths of light, leaving certain colors. Okay, I did not have the zinc chloride that it requested, but I do have some tin chloride, so I thought that might be interesting. So there is something happening. Bubbles. That's weird. Okay, and then there's another one. No reaction. No reaction. No reaction. No reaction. Well, there goes so much for being interesting, eh? Other than those little bit of bubbles at the beginning, I'm not really seeing anything exciting here. And those bubbles, I think, are just from the dropper. So no reaction. So tin in the same group as lead, but one up from there, and it is soluble. So a little bit of a smaller molecule, maybe has maybe better bonding with oxygen. No reactions. Okay. Surprised about that one, but this one is also a very old solution. So sometimes when the solutions are very old, all the tin might already be out of solution. It might have already formed some sort of solid down at the bottom. So see the white precipitate at the bottom of the solution. So that's one thing to always consider, is making fresh solutions before doing an experiment, just in case. I do want to show you one last example, which is a very fun one. It's called the, it was sometimes done as the yellow rain experiment or whatever, and you take some lead nitrate and some potassium iodide, and those are two of the compounds that we did not mix together, and let me see, it's a good spot for it. You get a very strong yellow appearance, and you can even, like, if you time it out right, you can kind of make them, oops, oh no, I've contaminated that now. Okay, so it actually was fast enough that it went up inside of the pipette. So that chemical reaction is very strong, very fast. You can see how strong and yellow that is. That's the reaction of potassium iodide plus lead nitrate. So Ki plus lead nitrate. So give that a look and see, think about that. I will post a related assignment for this so that you can write out the various chemical equations and see if what we predicted or what we observed matches what we predicted. Thank you.